Hello everyone. Aslema. Today I'm going to present a presentation about explainable AI. We are going to talk more about explainability and explainable AI and the difference between the AI models, the explainable AI models, and the difference in the architect, the pipeline structures, and the difference even in the mathematical parts. So, as present, my name is محمد مرتضى, 24 years old, from Tunisia. AI expert, senior XAI engineer at Netflix, XAI researcher at St. Mary University, and AI consultant with Degas and Weaving. So, you can scan this QR code to get to contact me through LinkedIn, to know the project I worked on, the next project on GitHub, and to check all my accounts, even to take one-on-one meetings with me. As a start, we are going to talk more about the explainable artificial intelligence. So, explainable artificial intelligence is a set of processes and methods that allow humans. The humans, what I mean about the human? The human is us, the users of the explainable AI models, engineers or developers, to build the bridge of trust between me and my model. And the human trust to comprehend and trust the results and output created by machine learning algorithms is important when we are working in sensitive fields such as finance or healthcare, or even in our real life social neural network between each others. Next, why do we need explainable AI when we have just basic AI? So, is for reasons. First is the transparency, the accountability, the trust, the interpretability, and finally the real-time optimization. And I need to put 3 lines under the real-time optimization because it's the most important part when we are working with artificial intelligence models. And the optimization is sometimes difficult to made after building the whole set of algorithms and after building the whole AI model. So, as we know, AI is built in 3 types: core, output, model, and then the output. But as we know, when we get the output through the model of artificial intelligence models, we don't know how this model works. We don't get it. We just get the output. We check sometimes the accuracy, the laws of the function we're building, but in the deep down, we don't know how this AI model work, how this AI give us the result, the approach, the pipeline, how we use the certain mathematical things. And now, for example, in generative AI, we just built an AI based on large language model, and this large language model give an output based on the prompt of the user. So, for example, in ChatGPT by OpenAI, you just sit and type the prompt, and when you type the prompt, the AI model work his magic and give you an output is a text in form of your response to answer your question. And this text is something you want, or you need to modify something with another prompt to get the final result. But in the real time, you are not knowing how this AI works, how this AI gives you this output, when you need to know why. The why needed if you are working in another sector, like the healthcare sector, for example. Um, think with me, if this output you get not just an answer for a code problem you get, or an answer for some paragraph you need to write. Think if this answer is a transcript or a treatment for a heart disease or something. So now we are talking in critical subject. So you need to know the why. You ask the model himself why you give these results. Is it trusty to use this treatment you recommend or not? You need to know that. But You are not waiting for just words, because words as humans we don't trust. So we need to see facts, and facts in for AI model is just math, and this math is representable in shape of facts. So those equations that we are going to see through the output of explainable AI model, both with the first output of the first pipeline from the first AI model, so we are getting two outputs, predictions and explanations. And those are going to give us the core of the principles of the XAI model to build a trusty model. So XAI is built on three core principles. The first one, as we see in the screen, interpretability. The second is transparency and accountability. Interpretability means making AI prediction understandable. It's critical, especially in fields like healthcare, as we talked previously, where decisions impact lives. When we are talking about human lives, transparency is about revealing how models arrive at their conclusion, reducing the black box effect. We will talk next how black box effects are built through AI, because as I said, AI just input model, whatever model you are going to build, machine learning, deep learning model, and output the results, but it's all built on a black box shape. You don't know how the model core are working. The final important part of XAI is accountability. Is to ensure that decision can be traced, justified, which is essential for trust in sensitive applications like criminal justice or hiring. So, hiring or justice are needed to make a very, very, very sensitive decision. And this decision needs to be traced and justified. Sometimes fraud are made. Maybe a hiring manager know this new engineers and he recruited him from his family or something, but he didn't have the skills needed to complete the position and to do the hard task or something or whatever the company do. So with the XAI model, he chose this candidate through different aspects and different features, and those features are trusty. Why they are trusty? Because are built in through XAI models. He give us the why, and when we got the why, we got it, and we trust the process and give it a bonus, and we will talk how the bonus work. So nowadays, this is the representation of how the AI model work. It's training the data, give it the data as output, then we put it inside the machine learning process, and this machine learning process learn from its mistakes, or it learn from why we are going to build this model through training, overtraining, overtraining, and then the decision or recommendation are made. But as a developer, I don't know how. I don't know how this model work and how this model give me this result. Now, through the XAI models, it's the same pipeline, but we integrate a new model inside. Is the explainable AI model. It gives us the explainability to the user, and when the user saw this explainable interface, that is the output of the new machine learning process through XAI, we can get it and we can say, yeah, now I know how this model works and how this model explain and how this model, sorry, and how this model go in certain approach and I can optimize the first AI model that I built through those explanation. So for example, if I know how many weights or biases this model worked in with, or how many core nodes for graph, for example, I can optimize and get the results I want. So next, we are going to see the architect of explainable AI. Just a second. Okay. Again, though the explainable AI are built with transparency, causality, privacy, fairness, trust, usability, and reliability. For the privacy part, can the protection of sensitive user information be granted? So the explainable AI answer with yes, because we are going to see how privacy for companies or for private discussion between doctor and patient can be maintained through explainable AI models integrated into the platforms, and it maintain the trust, the fairness, also the transparency, as I said before, the reliability and the visibility for the model. So now, approach to XAI. There are different approaches within explainable artificial intelligence. So, but I'm going to talk about four. The interpretability help us understand the behavior of the models. The explainability let us clarify specific outputs or decisions. Just I'm going to show you something to understand why I'm going to talk about those parts. Just a second. Okay. The post-hoc explainability, which means creating explanation for models after they build. And finally, feature importance scores reveal which data inputs most influence. And how to understand all this, we need to see the biggest picture. The biggest picture is the graph representing how the XAI works and how this architect are maintained. So here, you can take a screenshot or something, or you can look at the description to see this presentation. First, XAI is the center here. He is the main node of the whole architect. We have explainable models and interpretable models. For the interpretable models, they are principles. And those principles are feature importance, decision rules, and trends. So, the techniques for interpretability models. For the feature importance, we have linear models such as MA's Updative Learning Model, MMA. Decision trees, we have FDT and FTS. For the attention mechanism, we have ILCM, ATLCM, and Magnum MTs. For the fuzzy logic, we have EE5. For the graph, we have TCNs and mask crazy algorithm, the hybrid technique. You can see all the models we can build, and there are more. And for the decision rules, we are going to work with the decision tree and rule based. So we have those models. They are explainable AI models, not just basic models. And explainable models here are shape, line, IG, LRP, deep fix, and deep glue, and finally lempty. Lempty is for perturbation, deep fix and deep glue as for visual interface, to make the visual interface, and for the propagation we have LRP or IG, and shape and line for perturbations. Those are to work on the feature importance. And today we are going to focus on shape and line because they are the most famous explainable AI models, and the rest are in the research field for now, and they are everyday evolution to make the best frameworks or and the best libraries to just import one of them and to work on it. So for today we are going to just explain how shape work and how line work, and how the difference between a basic AI model and an explainable AI model when we integrate shape and line inside the model, and how the output going to be presented. Next, explainable AI. Here, as we see, we are seeing presentation of how me as a user going to use explainable AI through this graph. So AI or XAI going to start with an input data, whatever data type are going to made. So here are the your way to make a basic AI model, just to put this input data inside a machine learning model, whatever machine learning model you are going to build. Then, as a result, you are getting prediction, and those predictions are going to be printed into user interface. And this user interface, the domain expert, data scientist, developers, or even manager business going, whatever stakeholder are going to see those predictions, and through these predictions he is going to tell if yes we are now getting the right decisions or not. But if we are working in a field that need why, how we got those results and from where we got these results, and how to approach the approach used in this, we don't have these answers, because all we know as an engineers is that we put some amount of data inside the model, mathematical model, and get the output, and we stop there. And if anyone asks us why, we just maybe pretend to say the accuracy is high, we will talk some math, and we will say we have 100% accuracy, uh, and that is not an answer. The client or the manager, he needs the why to get the trust between you and him, and to get to know how to trust his engineers and how this product going to be sold, because any manager has his products to be sold, and people going to ask questions, and those questions are needed to be explained to build trust. Now the second trust link going to be with the client, the manager, and the manager with you. And as clients or buyers for certain product, we are in a position to ask the why, to get the trust link between each other, to give our money to get product that we admire or we desire. So engineers create another pipeline, as we see here. It's similar to the pipeline of the ML model, the AI model. It's parallel to it, and this model is just like that. The XAI methods or model, it get the ML model's input and the inputs of the data of the first AI models, and give us explanation. And those explanations are going to be printed side by side with the predictions from the first ML models in the user interface. So the domain expert, the data scientist, developer, AI engineer, or the client himself now seeing two outputs, the predictions and the answers of what questions he needs, how these outputs are made, how we can optimize them, and how we got the results through each steps, through each way, or through each application. So Chanda Babu designed this presentation to see how the black box effects are relieved. So, firstly, as an AI engineer, I'm going to do the data collection part, then the data pre-processing part. After the data pre-processing part, I'm going to do the modeling and the evaluation. For the modeling part, I'm going to use what model I'm desired to work on, such as machine learning model, deep learning model, or even generative AI. Then I'm going to do the training of evaluation again. Then I'm going to see results. But those results, in 100% of the time, without the post-modeling explainability, it's a black box. Even the feature engineering or the tuning of the hyperparameter not going to satisfy my reason, and to alleviate this black box thing and to know how this AI model work. So we need the integration of pre-modeling explainability through transformation and analysis, and these predictions going to be again looped through the human itself and the model itself, and then the training begin again, and after evaluation we are getting the post modeling explainability to know the model specifics and the diagnosis of the model, and even a visualization of what we just did through the model, and then we got what we want, explanations of the work of the model. Okay, now, we are, as I said in the first of the presentation, I'm going to focus on shape today and line, and those are interpretability techniques. So, as start, what's shape and what's line? Shape is based on shapely values from game theory. It assigns credits to each features for its influence on prediction. For example, shape can be used in credit scoring to show how each factor, like income or credit history, influence on individuals' credit worthiness. And for LIME it stands for local interpretable models, agnostics, explanation. It approximately complex predictions with simpler method models, especially useful in cases like image recognition, where we want to understand why a model classified an image in a certain way. You know the famous image recognition project, when we start learning little bit about data science and AI engineering, is the classification and the predictions of cats and dogs images. And now we can use the same example to understand how explainable AI work. Next, in the next slide, I'm going to share how image recognition through line and shape optimize through those explainable AI models to alleviate the interpretability of the model. As we see here, as a data input, we are going to put an image, and this image going to be in Inception v3 model, freeze layers of model. Then we are going to do the polling, are going to do the global average polling 2D, and then to dance the layer again. To activate the activation function, we are selecting the famous one, reload, and then the dropout is 30% here. Again, I'm going to put it in another dance layer, another activation function. We get the same dropout, optimized dropout, but the nodes are different. Then the dense layer with the BC, 1 unit sigmoid. Then the output layer. And this output layer going to be compiled into a model. And then the visualization going to be through line and shape. Now, I'm going to show how this presentation different to the output presentable or printable through a basic AI model. As we see here, for shape, at right, you see the model, the AI model, and the explanation. The AI model I represent as black because to maintain the idea of a black box. As you see here, the model gives us the age, the sex, the PPMI, the output, and the base rate. But we don't know how the model actually works. And in the next slide, we see the same output, but with explanation. And this explanation help us to optimize the first output and to get correct age. Maybe this person, he is just 6 years old, so we get the exact thing through those mathematical representations, and then we got the optimization we want. Next, this is the architecture part of the line. It's the same after the training and pre-processing and the feature selection and all. We take the model here as the classifier, as I'm going to use next in the coding part, throw line, and we get the output, and the output in form of visualization to know how the model work, and then we can put it again inside the classifier, and this classifier going to give us a second output, because the lime model is based on the testing samples. Get as an input the testing samples that are actually built through they are the outputs of the first AI models, and then put them again in the classifier and get the second output. Next, ethics of explainable AI. We use explainable AI nowadays to integrate the bridge between the orphans AI, the basic AI models, and to get the responsible AI. Those responsible AI is the goal of the humanity as a reason for the extensive use of AI now. And though this extensive use of AI give us the right and the community of each big company, as Netflix, for example, to set certain rules for engineers to build something responsible. And how we can explain this responsibility in form of what? In form of explainable AI models integrated into their platforms or their services to maintain the responsibility between the user and the company and the engineer. Ethics is fundamentals in explainable AI. Ethical AI align models with societal values, promoting fairness and preventing harm. For example, in healthcare, we need transparency. Healthcare section. I'm insisting in the healthcare section because he is so sensitive. So, in the healthcare section, I'm going to work next to give two examples with AI model and XAI model to show the difference in the healthcare field. To ensure that diagnosis or treatment recommendations are based on justifiable reasoning. Transparency promotes accountability, which is critical for industries where AI could impact people's well-being or livelihoods. So now we are going to see the pyramid of ethical AI applications. Organization, as I told, needs a guide for creating AI models that are transparent, based, learned and adaptable, and exist in support of societal laws and norms. As we see here, the basic AI models are in the bottom of the pyramid. The orphaned AI models, one of AI ML models never engineered to be reusable, and for the reusable AI ML models, composable, reusable, continuously learning and adapting AI ML analytics models. And then now we are working in the explainable AI models, who is the first step through the responsibility. He gives us the ability to understand, quantify the impact that individuals' metrics have on the AI model result. And finally, the responsible AI, he is the ethical one, transparent, accountable applications of AI in a manner consistent with user expectation, organizational value, and societal laws and norms. XAI in practice now. We are going to talk about some case studies of how explainable AI applied. XAI isn't just theoretical, it's actively making a difference across various sectors. Healthcare, XAI helps doctor trust disease prediction model, improving doctor-patient relationship. Finance, explainable credit scoring models allow lenders to make fairer and more justifiable lean decisions. And finally, in the IT operation, or as we said, AI ops, explainable AI optimize system maintenance by explaining automated actions, helping businesses avoid costly outages. Now, we need to take a brief look about how the XAI CDC's framework work. For the scope based for the data analytic explanations, those are some features of how the XAI going to help us. If we are working in the data or the model explainability, whatever model we are going to work, or even on the visualization part. For example, here, the disease detection, the doctor suspect lung cancer in a patient through A chest X-ray shows a shadow that is suspicious lung cancer. Then, the bedside decisions report, answering required explanations why we get this notification to correct hyperkalemia, the treatment for the treatment and prescriptions. The doctor give antidepressant or broken wrist or whatever issue the patient get through personalized treatment, and then the clinical practice. How we integrate XAI into AI project? We can integrate explainable AI into artificial intelligence project. We need to start with simpler models when possible. Complex models aren't always necessary, and simple ones are often easier to interpret. Use popular libraries like Shape, Lime, LA5. They offer tools that make explanation straightforward. Test XAI method and training data before deployment, allowing time to identify, to know more where the models might need adjustment. These steps make explainable AI more accessible in real-time application. Now I'm going to show some technical parts of XAI before getting into the Q&A sections. So, do you see? Just I'm waiting for it to be shared. Just wait with me, please. So I put all the code in the team of DevMina put this code lines into the description. So you can just click it on your side and open it, and we are going to explain the code line by line. So here, hopefully the code is shared with you. So we are here at DevMina 2024 presenting Explainable AI Unleashed through those AI and XAI models to bring the clarity to the complex world or the black box world of artificial intelligence. So to highlight the advantages of explainable AI over standard AI models, we are going to create two models. Firstly, a basic AI models using just a simple classifier. Just I need to give access. I don't know how to give you access. Just copying and share. Is it clear the code or not before share network? Let me just give access. Anyone with the link? Done. Do you have the access now? So when I get the okay with the team to share with you the access for the DevMena repos, is it okay now? Okay. So we are going to work with the basic AI models using just simple classifier, and the second one we are going to enhance this AI model through XAI methods, shape and line. We are going to do the same classifier but with explanations using shape and line. For this example, we'll use dataset like XAI heart disease. If you hear about XAI heart disease, dataset is a famous dataset for heart disease. which is widely used for classification tasks, prediction, whether a patient is likely to have heart disease based on various health metrics. We are going to demonstrate these models with a logistic regression classifier to keep things straightforward. So, code outline. We are going to start with the basics of the AI model. Firstly, we are going to install Line. So, engineers already built all the packages needed through this library. You just needed to install it and to make it inside your local environment you are already working on, whatever IDE, VS Code, or here today we are using Google Colab. Then the same for the shape is already built, so all you need is just to install it through pip install shape lime. When we install the necessary packages from shape and lime, we are going to start. So all the requirement already satisfied. Here our basic AI models without XAI. We are going to train a logistic regression model and check the prediction accuracy without explanation. And the model provide single accuracy scores but lack insight into why the model makes certain prediction. So our basic models here just the needed libraries we are going to work with: pandas, scikit-learn, and here finally we are going to load iris for just the demonstration, sorry, and you can replace it with the heart disease dataset and it's going to work perfectly. For this example, we are using dataset like as a ACI heart disease, but we are going to load iris the same for the classification. So here we're loading the dataset, we get the data, then the data frame, the target, we train the test part, and the fitting the model, and finally we want to see if the model is correct or not through accuracy. When we run it, the output are going to work on is accuracy. We see how the accuracy of this model, and through this number we're getting here, we are going to change the parameters of the model to optimize more the model accuracy, just like that. But if we don't know how this accuracy work, we are going to consume more and more time. See, here is just 5 lines of code, nothing big or nothing important work. Think if you are working with a large language model, for example, with 7 billion feature, or you are working with RAG model or something, or importing code inside the platform, and you just needed to build your work through actions or feature engineering, you are going to spend a lot of time just knowing how I got the result of my AI models and how I got this number. I need to know why. But through XAI models you're gonna show next, you are going to see how these XAI models actually work. So you know the magic inside it, and you can try to optimize through the next result you are going to see. So here our output just number of accuracy. Here is 100%. So you say, yeah, my model is so good and I'm going to deliver it to my manager. And when your manager asks you why or how you get this 100%, your answer is like that. I just built a prediction model through logistic regression, and I give it the data set and I use some metrics and some numbers, and the model give me this accuracy. Oh, the manager, he will say, but this is not the answer for his question. He need to know why and the approach you did. And the approach here is not as representable. So the next part is gonna save you is the XAI models. So you can answer the questions of your managers. The XAI enhanced model, now we are going to work with shape and line. So shapely adaptable, additive explanation, and line is local interpretable model agnostics explanation. Firstly, we are going to use shape visualization is give us the breakdown of each feature, contribution to a particular prediction, providing a clear understanding of the model decision making. So now, this shape model, he is going to add a new output side by side with the predictions of the first output, or the accuracy you got is 100%. So we are waiting for 100% accuracy. We are not going to implement a model to change the accuracy or to make it minus this number like 90% or something. Not that the goal. You need to obtain the same accuracy and the same model. We are not going to make difference through the model. We are going to use the same regression model, the same classifier, and we need to get extra output. The extra output going to be visualization of particular predictions to provide us a clear understanding of the decision making of the AI model. So as the same demonstration, I use the same packages and the same libraries, but my addition part here, this is my secret key. I leave the secrets of the first AI models is the integration of shape. I loaded the R's dataset. Then here, the targets, the data frame. I split the data into training and testings. As previous I said, then I train my model through the same model as we see the same metrics here. The logistic regression. So, and then I'm going to fit through XAI model. Is the model through shape. The evaluation going to be the same. I want to see the accuracy of my model. Here, the part of the explanation part. Here, use the shape explainability, the explainer. It takes the XAI model, it takes the X-train part, and then based on the training, is going to make a visual representation of what prediction necessities and how we got this 100%. Then we need to compute shape values for data, for the test data, and then we need the visualization. And this visualization is the reason to knowing why the model work. Shape values for a single prediction. So we need we can change the instance here to the first, the second, the third, or whatever instance we need. For example, we are going to take the first instance to work on, and as we see here, instead of slicing shape values directly, we use point values properly and to select the class that we are going to work on and the instance that we are going to show. So my output is like that. The accuracy doesn't change, it's 100%. So I'm safe. The same accuracy here, nothing changed at all. We got a good accuracy for my model, for my artificial intelligence model, and here the new output, as we see, is based on the explanation of the shape. So we see here the petal length and width through the average impact of the model output, the mean square errors of the shape value, and through those explanations we are going to put them inside the line, and the line output will show us how features contribution to the final prediction for specific instance. So we are not going to stop here because, as I said, shape give us just a breakdown of each feature contribution to a particular prediction. The particular prediction is the instance I'm working on. I put the first instance. I can put the second instance or the third or whatever instance I want, or I can align each instance as a site in code-based snippets to see how the breakdown work, and this providing me a clear understanding of the decision making. So the decision making are based through these graphs here. So this is the first step. Second step, to know more about my model, I used Lime, and the Lime output will show me how each features contribute to the final prediction. For specific instance, we are going to work with the same instance as shape and explaining the local behavior of the model. So Lime, again, show how each feature contribute to the final prediction for a specific instance, and it explains the local behavior of the model. Understand? I use the same data, the same slicing, the same splitting, the same training parts for the XAI model, the evaluation. As we see, we need to get the accuracy. Then I created the Lime explainer. The Lime explainer is creating through training data. It gets the values of the training data. The features are the columns, and then the class names of are modifiable based on the targets we are working on. Then classification mode. So I'm working here with the first instance in the text set, as I said here, the same instance index in the shape targets. This is the first instance that we visualize here in the shape model. So in the line, as the same, we are going to predict this instance through the explainer of line. So as we see here, we got accuracy not changed, but we got representation. Oh, so this representation, as we see here, it's some math equation, mathematical results, and those mathematical results represent the facts and the features values of how the model work. We see here how the decision making are made through those numbers, and those numbers validate how our XAI models work. So the output show us each features, how those results are the keys to contribute to the final decision of the AI model. So, as a summary, the basic AI models here is simple. Give me just accuracy score, but as we see, there are lacks of interpretability. We don't know how the AI model work. We don't know how we got those interactions, how we got this prediction. But the XAI enhanced model using shape and line, we gain a lot of things. We gain insights into how individual features impact predictions. It provides us transparency, helping me as a user to trust and validate the model decision. By comparing the two, we can see how XAI techniques, explainable AI techniques, give more interpretability and making the model decision more transparent and actionable. Next. Hopefully the code is clear for you all. So we need to present, and as final part, I don't know if the time is set or not. So here I'm going to just assist on one more thing. So we was working here with shape and line. We inserted them inside our classification model to assist in the feature importance. The feature importance for the previous dataset are the length of the petal, the width, and those are the most features I want to work on. And the important features are give me the result, the accuracy results, and the explanation results. So if you want more about visual explanations, We can use aside by shape and dam, we can use deepfix or deep glue, and those for the explanation part. And if you are going to work into interpretable part, you can use whatever model here. So this is the most important slide in the presentation. And finally, thank you for your attention. I hope this session with Dev Mina has shed light on explainable AI role in building responsible, transparent, and ethical AI. We know all that explainable AI is new field. So and he is the future of the AI models because of the extensive use nowadays and the consummation of the user of the AI. We see all the platforms or the application, the game are going to integrate AI features. So you need to make rules, and those rules are going to be just as I said. You need to integrate XAI models. Aside each AI model you are going to build is a new feature based on AI. Now, I'd love to answer any question. You might have also feel free to connect with me through LinkedIn, GitHub, Medium, or even LeetCode to see problem-solving parts. Let's continue this journey toward a future where AI is both powerful and trusted by all. So, if you have any question, just put it in the comment section and I'm going to answer it. Just I'm going to see the comment part. Do you have any questions about explainability or something I can assist you with? Don't hesitate to ask any questions. We got some time to answer all the questions you could think about explainable AI. I guess there is no question, or do you have questions? I guess no. So again, thank you so much. You can watch again this presentation, this code, or the code and the presentation are in the link of the description of DevMina YouTube channel. If you have any question related to papers on explainable AI or code explanation, you can reach me through I forget to share again, share screen. Okay, here. So you can reach with me just through scanning the QR code in the screen, and you can ask me whatever questions you want. I will answer all your questions. Again, thank you so much for your time and for your energy toward this field. And let's continue this journey toward a future where AI is both powerful and trusted by all. Thank you so much. See you in another session by Dev, Middle East and North Africa. Thank you.